Everyone, we will solve today's LeetCode problem. So it is an LeetCode medium one. Let's see what the question is. So the question title is Hand of Straights. So Alice has some number of cards and she wants to rearrange the cards into groups and so that each group is size of group size and they consist of group size consecutive cards. Given an integer add a hand where hand I is the value written on the ith card and integer group size return true if she can rearrange the cards or false otherwise. Okay. So we have given an array named hand, and we need to form we need to make the group size three, and the size the group which we form should be the number should be in consecutive order. What the consecutive means? Consecutive means it should have what the consecutive number means. It should have numbers just incremented by one, like 1 2 3 4 5 6. Like these types are numbers are consecutive numbers. So the difference of previous elements is one, right? 1 plus 1 2, 2 plus 1 is 3. So the consecutive means number is should be in only one incremented by this, right? So this, if you see 4 8 9, this is not a consecutive numbers, these are not a consecutive numbers, right? So that's the consecutive numbers. It is not a consecutive number, not a consecutive number, right? So we need to find the group size 3, and we need to make a group size 3, so that and we need to return either true or false whether we can group these elements in groups of size 3 consecutive numbers, right? So if we see first example, this 1 2 3 4 5 6 7 8. So if you see group size 3, so can we do that? Let's see. The first thing to check that for making groups of size group size, the the total number of elements, the total number of elements present in present in array should be divisible by divisible by the group size, right? That's for sure. Then I can make then I can simply make the groups like groups of size, the given size in groups, right? This should be divisible now. Suppose this is 3 and this is suppose this is group size is given 3 and the total number of elements are 8. So if I 8 do 8 modulus 3, it will not able to make group size of 3, because 3 3 and then it becomes 2, right? So it is not becoming it is not we cannot form the groups of size 3 anyhow, right? That's not possible. The first thing is to confirm that we need to the total number of element in present in array should be divisible by group size, right? That's for sure. So now the first observation is this, that we need to anyhow if first we check that this should be divisible, right? Second thing is how we will check that this is, suppose this is given, then we can form this 1 2 3, this group size. Again we can form like this. So see, this 1 2 3 gone, right? Now we will have left with 6. So 6 7 8, that can form 6 7 and 8 can form, right? Again we have left with 2, so 2 3 4 cannot form, right? So if you see, we are able to make three groups of group size with consecutive numbers, right? If you see here, so how we will simply how we will the question is now how we form the groups, or is it necessary to form the groups, or is it really necessary that we form the group? We form group. So if you have seen, we just need to return true or false. It means we don't need to return the groups, which groups can be formed. We just need to tell him that whether it is possible or not, right? So whether it is possible or not. So if you see here, what we are doing, we need to just, if I just count all the elements occurrences like this. Suppose this is given 1 2 3 okay, let's take example of this, given example this 1 2 3 like this. If we just take this, How many times 1 is present? It is present 1 times. 2 is present 2 times. 3 is present 2 times. Again 4 is present 1 times. 5 is not present. 6 is present 1 time. And 7 is present 1 time. 8 is present 1 time. Right? 8 is present 1 time. Right? Right. So here are the occurrences of count. Now we need to use these numbers to form groups simply, right? And that numbers, that groups should be consecutive. Keep it in mind that we need to form groups and that groups should be consecutive. That's enough to solve this question, right? So we will do exactly what the question is asking, that we will form consecutive groups by counting numbers simply, right? So suppose if I see here in this case one count is one, of course one count is one. So for forming group with one, for forming group with one, two, three, for forming group with one, with the group size three, these three numbers should be in my array and should be equal. All frequencies should be minimum frequencies should be satisfied, right? So if I want to make group starting with one, so so the number of elements, so the number of elements, so the number of elements which should be a part of this group should be equals to group size, right? So if you see here group size is 3, so 1 2 3 should be occurring, right? So the consecutive numbers till the size of given group size, till the given group size till the given group size should be available with me, should be available in array. And also the count which is started with one should also be present in two or three counts. Suppose this one is occurring one time, so two and three must be occurring one time. If this one is occurring two times, so this two and three must be occurring two times also. Why? Because if 1 2 3 is present, there can be another group which can be formed like 1 2 3, right? So if one is present three times, so we can't form another three groups with one to three, right? Because one is excessively available and two three are not left. So it means the number from which we start, also the number from we start which we start must have should have should we start the count of occurrences of number the count of occurrence of the number from which we start should be should the count of occurrence is should be present in all the occurrences of the numbers, right? So you understand what I'm trying to tell, right? Because if the one occurrences of count is greater than this two and three, so we can't form the groups now. So it should be the value numbers which should be present in this two and three, of course, right. The count of occurrence of the numbers which we want to group should be should be equals to equals to or greater than the starting number occurrences, right? Starting number occurrences, right? This is for sure, right? So what we are doing, we will just start from the first element, this first element. So if I start from first element for, so after that I will iterate till 1 to 1 to 1 plus 3, 1 plus 3, right? This is not included and this is included, right? This is not included, 1 plus 3, that is 4, and we need to find three groups, so 1 2 3 should be formed. This is not included and this should be included. So what I will do, I will check for each and every numbers from 1 to 3 that whether it is in my array or not, right? So what I will do, I will go for one, right, and I will check whether its occurrences is equals to my starting occurrence. So start number is one, right? So if I check one is one count is, and one count is what? Count of one, count of the start element is one. So for one, the count of start is one, and one is also present in my array, which is one. So I will, so one can be the part of a group, right? Again, now we'll go to two. Now for two, this the count of two is present two times, which is greater than this count of start, which is greater than the count of start. So we can take two, right? Now again, for three element, the third element is present two times, so we can take it three, right? Now again, I also need to decrease this count because I we have already taken this count for a group which we for a previous group, right? So if I take this one here, two here, and three here, so how many times we need to decrease the count of this two, three, and one? The count total count of will be this count of a start. So count of a start is one here, so we will decrement this one to zero, this to zero, and this to zero. So what we are doing, we are moving from starting element till group size element, and we are taking each and every element and checking that whether its count is greater than or equals to this count of the starting number, which is one. And if it is, then we are just decrementing their counts with the count of a start, right? Simply. Why we need to do that? Because for forming the group size, we need to iterate the same thing, right? For forming the group, we need to do that, right? So we are able to form this group. So till now we are able to form this group, right? Now this one to three, uh, one to three gone. Now for we check for two elements, because after one this two comes, but this two occurrences is zero already. It means we have already formed this with this group, so we can't take this two. We can't again. Sorry, this should be one now. Okay, this should be one. So we will start forming with two, right? Because two occurrences is left. So now what we do, this start element is not 2, count of start is now 1, because it is 1 left, right? Now we will start from 2, and this 2 plus 3 is 5, which is not included in our answer. Now we will start from 2th part. If we see 2, the count of occurrences is same, so we can take 2. We can take 2. Now we will start from 3. So 3 occurrences is greater than equals to the count of start, which is 1. So we can also take this 3. But we need to also minus this with 0, and this also with 0. Why? Because we have combined this 2 and 3 with my starting point, which is 2. So we are forming this group, right? Now again for 4, this 4 occurrences is equals to count of a start, greater than equals to count of a start. So we can take this 4. Now I will decrement this count with the count of a start, which is 0. Now we can form this group, right? So this is the another group which we can form. Till now we can form the group. Now after this 2, can we take 3 as a starting point? No, because it is not left. We can we take 4? No, it is also not left. Can we take 6? Yes, we can take 6. So now the starting point would be 6, and the count of occurrences is 1, and this should be 6 plus 6 plus 3 9, right? Now the starting point is 6, so we will check 6. This is equal with the starting point, so we can take this. Now again 7 is greater than equals to the starting point, so we can take this. Also we will decrease this count, and also for 8 the same thing happen, right? For same thing happen, right? So this is how we will solve the problem. So basically what we are doing, what we are doing, and if in any of the place, if in any of the place we are not able to form group, or the count of start is greater than this any of the occurrences of count, so we will return simply 0, right? So what we are doing, the final approach would be, the first thing is we will check the divisibility condition, right? That the total number of elements, the size of the array must be divisible by the group size given, the given group size, right? By the given group size, right? Second thing, we will count all the all the numbers occurred in array array, right? And we will check we will check we will take a starting point. We will take a starting number, of course. We will take a starting number, and each number, and check for each number till, and check for each number, each consecutive numbers from starting number to starting number plus group size minus 1, because the 1 plus 3 is 4 and 4 cannot be included, so group size minus 1. And check whether all the occurrences of each numbers, all if whether occurrence of each number is should be greater than, should be must be greater than, should be not must be greater than, must be greater than equals to must be greater than or equals to the starting number count, right? The starting number count, right? This must be included. And if it is greater than this, then we will simply uh, we will we will decrease the count of that number with decrease the count of number by the starting number occurrence count, the starting number count, right? We are just minusing different we will just decrement it by the starting number count, because that will be take all the that will take all the numbers which we are present, right? And if we are able to do this, and if we are able to do this with all the numbers, with all the numbers, it means can form the group we can form the group. Otherwise, otherwise the answer will be the answer will be false, right? Answer will be false. Sure. So this is how we will solve this question. Let's try to implement this. Okay, so for counting purpose, what we take, for counting purpose, we will use map hash map. We will use a hash map, right? We will use a hash map for that, simply for counting purpose. And for checking each and individual starting point, the map what the map do, map stores all the numbers in sorted order. Map stores all the numbers in sorted order, all the numbers in sorted order. So what we'll do, we will simply check, start from first element and check till group size, then again go to 2, then again check group size, then again go 3, then again check group size. So this is how we will solve this. So let's try to implement this, because that will be help you to better understand. So this is hand dot size. Let's take this group size as k, right? Now what we will do, we will take a map. We will just store all the elements in map. We will just store all the elements in map. That would be it plus plus. Now what we'll do, we will go through each and every element in map. And what we'll do, uh, we will start iterating from this it dot first. The it dot first will be the number till where, till it dot first plus this group size, which is k. And what we will do, we will check for each and every element, that whether it is each and every element, whether it exists in my map or not, right? And if it exists, it should be must be greater than frequencies with this mp of it dot first, right? This should be occurrences, right? So for that, what I will do, I will store the occurrence. I will store the occurrence. The first number would be it dot first. The first number in this will be our it dot first. and if it is it dot first is greater than, if it is greater than, if it is greater than 0, it means we can take this number as a starting point, right? We can take this number as a starting point. So if the number count of occurrences of this starting number is greater than 0, it means we can start from this point. And if we can start from this point, so we will start and move till group size and check for each and every elements in this I, that whether the occurrences of this I is greater than equals to the occurrences of here, which is occurred occurrences, right, which is occurrences. And if it is, then we will just decrement this with occurrences, right? We will just decrement this with occurrences. Why I'm not taking mpit dot first here? Because the first number is it dot first. If I decrement mpit dot first here, so that will not able to check for further numbers, right? Instead of this occurrence, if I use mpit dot first, so that will be updated now in for after the first elements, that will be updated. So that's why I'm just including it dot second in another variable and using that, right? If it is not equal, if it is not greater than equals to 0, it means we will not able to find from the group, we will not able to form the group if it is greater, less than occurs, right? So yeah, this is how we can solve this problem. We will check each and every element if it is present in my map. If it is not easily used, we will check for each and consecutive numbers, and that will be answer. After that, if we are able to do that all, we will return true, right? So this is how we will solve this question. Let's try to run this. We have passed a sample case. Let's submit it. Yeah, we have passed all the test cases. Now the thing is, what will be the time in the space complexity? So the time complexity would be, the first thing, we are taking a map and checking for each and every inserting all the numbers in map. So that will definitely take O of n, of course, right? Plus, for each and every element, so uh, that will be the total number of unique numbers. So let's take m is the m is the m is the total unique numbers, unique numbers present in array. So for each and every unique elements, we are checking for m for that, whether this group size is can be formed, right? So if we take group size as a k, which we have taken k, so that would be m, of course. And for each and every occurrences for so that would be m into k in the worst case, in the worst case. But if you see here, that we are decrementing this. So first we are checking that whether it is greater than 0 or not. So most of the cases, in most of the cases, this will be we will not run this for loop, right? In most of the cases, we will not run this for loop. But if you talk about the worst case, we can take this as m into k. We can take this as m into k. Okay. And one thing more, that this map, this after this inserting in this map, it takes it is sorted all the elements, right? So if we have n elements, so in this map it will take f and log n, right? So it will take n into log of n, right? So that would be okay, that would be the, it will not take n log n, it will take m into log n, because this m is the unique number of present in this array. So it will take n for m into log n, right? M into log n, because the total unique numbers is m, so it will take m into log n plus o n plus o of m into k, right? So basically, this m into k is very in the very worst case, because but most of the time we will not run this for loop, because most of the time this mpi would be becomes less than equals to 0, right? So most of the time we will not run this. So that's why this passed. If we take about the constants are 10 to the power 4 only. So, and group size also 10 to the power 4. So 10 to the power 4 into 10 to the power 4 becomes 10 to the power 8. But this is exactly not an O of n square. it is very much less than of n square. That's why it passed. This m into k will be, can be the overall time complexity can be taken as this m log of m, right? So this can be taken as m log of m, or you can take this as further for m and log of n. Why? Because this is this for loop. So you can also take this as uh, o of and log of n in the worst case, because this k part, this k part, this m into k part in this, because most of the time this will, this for loop will not able to run. Most of the time this will not able to run because we are decrementing the count after every group size, right? So the average time of complexity can be taken as o of n log of n or m log of m, right? And the space complexity would be, so the space complexity would be, so if we see here, we are taking a map to store this all the elements, and yeah, rest of this we are not taking anything, so that would we take o of n, of course. So this is how we will solve this question. We can also we can also use unordered map for that, but that will be the same approach, that will the same approach for that, that will be the same approach for but for another map we need to decrement that in previous, we for if we take another map, if we take unordered map, we need to we need to first find the starting element for each element, for each element. Why? Because unordered map don't give us in sorted order. So for that I need to find the starting point for each element, and rest of the process, if we after that, if we if we find the starting element, the rest process will be the same, right? The rest process will be the same. Rest process will be the same. So what the benefit of using the unordered map? So if we use unordered map, this m log m, this m log m will be reduced to o of 1, right? This m log m will reduce to o of n only, right? So this would be left out, this would be not needed, and this is the average condition. So this n log of n can be reduced to o of n, of course, right? This can be reduced to, this will be reduced to o of n in average case also scenario, right? So I'm not telling you of that approach. You should try this, that if you take another map, you need to find starting for each element, and rest process will be the same, right? So that's the benefit of using this another map, because that will not take m log mf. So yeah, thank you so much, hope you understand it. Thank you. Bye bye.